So welcome students. In this topic, let us look at how to find the circumradius and inradius of a regular polygon. So let us say that you have an n-sided regular polygon. N-sided regular polygon whose length of side is A. So let us say that the side is A units and C be the center of the regular polygon. So let C be the center of polygon. So now from C, join any two adjacent vertices of the regular polygon. That is, from C, join A and B, and also drop a perpendicular from C onto AB. Because this is a regular polygon, so whatever side you choose, you get the same measurements, right? Because the center of a regular polygon is symmetric with respect to each and every side of the polygon. So if C is the center and you choose one of the side AB as the base, so if you join CB and CA, both of these lengths will be same, and if you draw the perpendicular from C onto the base AB, so this length will be same for each and every side of the polygon. So let us take this as capital R and this as small r. Now if you take C as the center and draw a circle with radius r, if you take C as the center and draw a circle with radius r, so that circle will touch each and every side of the polygon because the perpendicular distance of C from each of this side is equal to small r. So the circle with center C and radius small r will be the inscribed circle of the polygon. So r is the in radius of the polygon. Similarly, if you draw the circle with center C and radius capital R, because each of these vertex are at same distance from C, so that circle will be the circumcircle of the polygon. That circle will be the circumcircle of the n-sided regular polygon. So if you want the circumscribed radius of this n-sided polygon, you just need to find this distance. If you want the inscribed radius, you need to just find this length. So how do I find this length? It's very simple. So what will this angle be? So this angle will be total 360 degrees divided by n sides, because each side subtends same angle at the center, and there are n sides subtend n thetas, and the total angle is equal to 2 pi radians. So this angle ACB is equal to 2 pi by n. This angle is 2 pi by n. Now, what is half of this angle? Because it's an isosceles triangle, the altitude will be also the angle bisector. So if this point is D, angle DCB is equal to 2 pi by n by 2 is pi by n. So this angle is pi by n. And because this total side is A, this is an isosceles triangle, the perpendicular will also be the median. So this dB will be equal to A by 2. That is, the altitude will also be the median, so it divides the opposite side into two equal parts. Now you have the angle, you have a 90 degrees and you have a side. By using different ratios, you can find smaller and capital R. First, let us use the ratio tan pi by n. So tan pi by n is equal to opposite side by adjacent side. Opposite side is A by 2, adjacent side is R. This implies R is equal to A by 2 tan pi by n. That is equal to A by 2 cot pi by n. So small r, that is the inscribed radius of a n-sided regular polygon of side A is A by 2 cot pi by n. Similarly, if you want capital R, we use the ratio sine. So sine pi by n is equal to opposite side by hypotenuse A by 2 capital R. This implies capital R is equal to A by 2 sine pi by n. If it goes to the numerator, it becomes cosecant pi by n. So capital R is equal to A by 2 cosecant pi by n, and small r is equal to A by 2 cot pi by n, where n is the number of sides and A is the side of the regular polygon. So this is how we derive the inscribed radius and the circumscribed radius of a regular polygon. So the ratio of the in radius to the circumradius. So if you want the radius of small r by capital R is equal to, so this A by 2 and A by 2 gets cancelled, cot pi by n by cosecant pi by n. That is equal to, effectively this is cos by sine, this is 1 by sine. Sine and sine gets cancelled, is equal to cos pi by n. So the ratio of the in radius and circumradius of a regular polygon will be cos of pi by number of sides. For example, if the number of sides is equal to 3, so this will be cos pi by 3, which is equal to half. That means in a regular triangle, that is an equilateral triangle, small r by capital R is equal to 1:2. So if you take a 4-sided regular polygon, which is a square, the ratio of small r to capital R is cos of pi by 4. This is 1 by root 2. Similarly, as n changes, the ratio of r by r changes, and as n goes larger and larger, this becomes cos of pi by a very large number. So this tends to cos 0, it tends to 1. That means as the number of sides increases, the value of small r goes very close to the value of capital R. Thank you.